Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of interpreting exponential functions. This is standard A.9B in the great state of Texas, and we are using item number 31 off the 2017 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a student using this exponential function here to show how the balance in a savings account will increase over time. Alright, so we need to figure out what that 5 represents, but let's make a connection here because hopefully we remember from 7th and 8th grade that we calculated both simple interest and compound interest. So this is how we found compound interest. A equals, and this is straight from the mathematics chart on the 7th and 8th grade STAAR test, P and 1 plus R to the T power. So we have labeled these in the past as the principal. So that's the amount of money that you would initially deposit, $1,000, $100, $50. It's 1 plus, and then this R was the rate, and it was always very important to add 1 to the rate. And then that T was just the time period. So per year, per month, however often you want to calculate that compound interest. The tricky part is always this 1 plus R, right? So let's say you have 5% interest rate compounded annually. Well, that would equal 0.05. But if you just put that 0.05 in there, what you're going to calculate is just the amount earned, but not your new total amount. And typically, people don't want to do 2 steps. They don't want to calculate the amount earned and then go back and add in the original amount. So all we need to do here is add the 1. And the 1.05 here, what this 1 does is this 1 calculates with the initial amount kept in there. You don't have to do that second step afterward. So you just keep that initial amount by multiplying by 1 and then 0.05. So let's look at these 3 numbers here. We've got the 5, we've got the 1.012, and then that x, which isn't really a number, but that's just going to be the time period. And we don't know what time period is, usually years if we're talking about interest here. So really, let's look at that 5 and then that 1.012. All right, so 5, remember if we go back to our compound interest formula there, your 5.00 equals your principal. Now the thing with compound interest is usually when you're given a problem like that, they would say no additional deposits or withdrawals, because if you keep depositing monthly into this savings account, your principal is going to change each month, right? So they would typically say it's no additional deposits or withdrawals. That's your principal. And then your 1.012, you notice that 1, right? Well, if we take that 1 away, what we're going to get is 0.12. Then if we move the decimal over 120, that equals a 1.2% interest rate. And what we did is we just added that 1 right there so we can keep that initial amount. So we've got a 1.2 interest rate and we deposited $5. Doesn't seem like a lot of money. And then the x is just going to be how many months or years. So A, 5 represents the interest the savings account earned. No, that's going to be this right here. That's 1.2%. B, the annual interest rate of the savings account. No, still at 1.2. The number of years the savings account interest has earned, that's the x. And then look at that D, the starting balance. The starting balance, that's your principal. That's how much you started with. And that's our answer D.